All right, so going back to E part is your book kind of wrongly assumes that your calculator won't be able to handle this. And in really old calculators back in the day, it wouldn't have been able to handle it wouldn't have been able to handle the data. It would have said an overflow error. And so that's why your book says try to perform, like try to perform the inverse transformation. No, we're actually going to perform it because our calculator can handle this. So what we do is we've got our original, or not our original equation, I should say, the log of y hat here. And what we need to do is back transform it, or as your book calls it, inverse transform it. Sometimes I like to say back transform because it reminds me of things better. But then I say base 10 raised to the equation that we found. And so then what I need to do is go to my stat plot, and I did this right before I restarted this video, but I need to change that X list back to list 2. Your calculator will probably still have list 3 in it, so change it back. See, that's why I like saying back transform. Change it back to list 2, and then zoom stat, graph it, and you wait on your calculator. Ah, ta-da! It can handle it, and it graphed an exponential curve to fit our data, which is awesome. So our original scatter plot is pictured here with a superimposed exponential curve. So you, again, if you were to put this on paper, go to your window, check that out, label both your X and your Y axis. So then what your book asks you to do on F part is to calculate the least squares regression line for years since. Well, the reason it does this is it's assuming our calculator couldn't handle the data for the years 1978, 1979, 1980, 1981. So there's really no purpose in this unless at some point your calculator can't handle data for certain years, or if you were using a statistical program that couldn't handle it. So what we're doing instead is we're going to change this to the first year, the second year, the third year, and the fourth year, 4 years since. And then from here, what we can do is, again, do a linear regression. I always like to choose number 8. And we'll do, again, list 1, comma, list 3, comma, vars, y vars, function, y1. Enter. Oh, I probably should have cleared everything out first. So I made a rookie mistake. I always forget though, clear and clear. And then go back to edit. And that should all be the same because we're taking the log of L2. So let's take a shot at this again. Stat, calc, vars, yvars. Or we'll do vars, yvars function and all that in a second. So let's try it again. Hopefully I'm not missing something, or I didn't forget to clear something else out. Yep, it did it. So I just needed to make sure those lists are cleared. I am notorious for forgetting that. Hopefully you guys will remember, clear your y equals, clear your y equals, clear, clear, clear. So then my new equation would be log y hat is 4.2513 plus 0.5558x. So the second part is still the same. And then what we are asked to do is to perform the, construct and interpret a residual plot. So what we can do from here to interpret our residual plot, there's a shortcut on your calculator for this, by the way. If you did not learn this in the residual section or did not pick up on this in your technology toolbox, instead of doing all the steps to find residuals, you can go down, because this is where you put your residuals. Remember, you had to calculate your residuals in one of your lists. So instead, you can do it all the steps if you'd like that you learned when you did residuals, but I just hit second stat, and then scroll down to resid for residuals, and then zoom stat. And my residuals are scattered, so there's no clear pattern. And so using your knowledge of what you learned about residuals in a past chapter is that the residual plot shows no clear pattern, so the linear regression model on the transformed data is appropriate. So our model would be appropriate here. And then the next step, H, is to perform the inverse transformation to express y as an exponential function. So our book is really having us kind of do the same thing we already did, just with the 1, 2, 3, 4 instead of the 1978, 79, 80, and 81. So H part's really a repeat. Not exactly, but what we would need to do is perform the inverse transformation on the new equation we just got. So base 10 raised to vars, y vars, function y1. So that would be stored there. And then what you could do is go back, so what we could do from here after we perform that inverse transformation, so the 10 raised to, the very last step is it says to make a prediction for 82. Well, since we already have the years since in there, think about what 1982, so I'll go over here. So 1982, years since 77. So that's 5 years since 1977. So what we want to do, you can go back to your home screen, go to vars, y vars, function, but we did our back transformation, our inverse transformation in y2. So there, we're going to choose y2 because we need to put in our years into our inverse transformation, and we can put in 5. Now, if you didn't do the years since, you would have put in your actual years here. And then you can see we get, wow. So like 10 million acres. And so that's our prediction for the numbers of acres defoliated in 1982. I hope this helped.